Let's talk about modules and crates in Rust. By the end of this session, you'll not only understand how to split your Rust code into modules and organize large projects, but also how to build and publish your own reusable crates on crates.io. So grab your editor, and let's get started structuring code like the pros. Okay, let's start with some fundamentals. In Rust, the smallest unit of code compilation is called a crate. Think of a crate as a package. It could be a binary crate, an executable like a command line tool, or a library crate, a reusable module you can include in other projects. And inside a crate, you can have multiple modules, which are just logical groupings of your code, functions, structs, enums, traits, etc. In other languages, you might call these packages or namespaces, but in Rust, we call them modules. So let's actually see this in action. Let's create a new Rust project using Cargo. You'll see we have a familiar structure, a cargo.toml file, and a main.rs. Let's open main.rs, and I'll remove the default Hello World line. Now, imagine we're building a restaurant management app. We might have modules like front of house for the customer-facing side and back of house for the kitchen and staff side. Let's create those. In Rust, you can define modules in two main ways, inline in the same file or in separate files. Let's start inline to keep things simple. Now, what's going on here? We've defined a module called front of house, and inside it, a submodule called hosting. The pub keyword means public. Without it, this function and module would only be visible inside this specific scope. That's because in Rust, everything is private by default. We have to explicitly expose things to make them usable from outside. Now, how do we actually call that function from main? Let's try this. And yes, this will work, but only if we make sure our modules and functions are pub. Let's break that path down. Crate refers to the root of our current crate, so think of it as our project's namespace. Then we go into the front of house module, then into hosting, and finally call the add to waitlist function. Let's run it with cargo run. Terminal output will look like this. Welcome to our restaurant. Added to waitlist. Awesome. It works. Okay, but this is going to get messy if we keep everything in one file, right? So let's move our front of house module to its own file. Inside the src directory, let's create a new file called frontofhouse.rs. In main.rs, we'll replace our inline module definition with module declaration or a module reference. And inside frontofhouse.rs, we'll put the module definition. Now our code structure is clean. Rust knows to look for a file named frontofhouse.rs when it sees mod frontofhouse in main.rs. This is the modular architecture that makes Rust projects maintainable at scale. What if we want to break this down even more? Say we want hosting itself to live in its own file inside a directory. We can do that too. Let's create a folder called front of house and move the hosting logic into a new file, hosting.rs. Inside frontofhouse.rs, we now write pubmod hosting. And in hosting.rs, we will write the function. When you run cargo run, everything still works the same. This hierarchical folder structure mirrors the module structure. Mod equals folder or file, and submodules are represented by files inside those folders. Let's now talk about privacy, because in Rust, this is a big deal. If I remove the pub keyword from hosting or from add to waitlist, and then try to call it from main, I'll get a compiler error. Function add to waitlist is private. Rust enforces strict boundaries between modules, and that's a good thing. It prevents accidental misuse of internal APIs. You can decide which parts of your module are exposed publicly and which parts stay private to maintain encapsulation. Now, that long path we write to call the function is kind of ugly, right? Rust has a solution, the use keyword. Let's update our main.rs by adding a use statement. Now our call is much cleaner. We can even bring the function directly into scope if we want. The use keyword is Rust's way of saying, bring this item into local scope so I can call it directly. It's super helpful for keeping code tidy and readable. Let's create another module to make this more realistic, a back of house module for kitchen operations. Inside backofhouse.rs, we'll add modules for cooking and serving. Now we can use these modules in main.rs like this. Run it and you'll see the output. Cooking order, serving order. Beautiful. This is modular programming in Rust, simple, clean, and perfectly scoped. Now let's take it one step further. What if we want to make this restaurant logic a reusable library so we can import it into other projects? Let's create a new library crate by running this command. Notice that instead of main.rs, we get a librs file. This file represents the root of the library crate. Let's move our code here. Inside librs, we will write all module definitions. Now we can build this library using command, cargo build. And if we want to use it in another project, we can just add this to that project's cargo.toml using path like this. Or if it's published on crates.io, we can add it like this. Then, in that project's code, we can use the library like this with updated use statements. That's it. You've just modularized your code into a reusable crate. Once your crate is ready, you can publish it to crates.io, so others can use it too. You just need a crates.io account. Log in using this command. Cargo login. Your API key. You need to use your API key here. And then publish your crate with this command, cargo publish. It's that simple. Your Rust library is now available for developers all around the world. All right, you now understand how modules help organize code, how to control visibility with pub, how to use mod and use effectively, and how to turn your project into a reusable crate. This is a huge milestone. From here, you can structure professional Rust applications and even contribute to the open-source Rust ecosystem.